Good day everyone. Our topic for today is Taylor and Maclaurin series. Uh, Taylor's formula with remainders. So let f be a function that is infinitely differentiable that uh, differentiable at x is equals to c. That is the derivatives if the f to the power of n times the quantity of c exists for all positive integers in. The Taylor series for f about c is the power series. So, this is the formula in Taylor series. So, where e this in is equals to f to the power of n times the quantity of c over n factorials for all n. Noted that if raised to the power of 0 is taken to mean that function f itself so that e bis 0 is equals to f of times the quantity of c. The Maclaurin series for f is the Taylor series for f about 0. That is the power series. So, the formula to get the Maclaurin series is this. So, where e bis n is equals to f raised to the power of n multiply the quantity of 0 for over in factorials for all n. So example, the Maclaurin series for sine x. So let f of x is equals to sine x. Then the for first derivative of f of x is equals to cos x, and the second derivative of, of cos x is equals negative sine x, and then the third derivative of sine x is equals to negative cos x. So since f raised to the power of 4 times the quantity of x is equals to sine x, further derivatives repeat the cycle of 4 functions, since sine 0 is equals to 0 and cos 0 is equals to 1. And f raised to the power of 2k times the quantity of 0 is equals to 0. And the f raised to the power of 2k plus 1 times the quantity of 0 is equals to negative 1 raised to the power of k. So hence, e bis 2k is equals to 0, and e bis 2k plus 1 is equals to negative 1 raised to the power of k over 2k plus 1 factorial. So that the Maclaurin series for sine x is equals to, so buisit ko. So the Maclaurin series for sine x is, so positive infinity to k is equals to 0 times the quantity of negative 1 over k divide over 2k plus 1 factorials x times x to 2k plus 1 is equals to x minus, so x cubed over 3 factorials plus x raised to the power of 5 over 5 factorials minus x raised to the power of 7 over 7 factorials plus so on. So, another example, let us find the Maclaurin series for f of x is equals to 1 over 1 minus x. So, first, the f of x is equals to 1 over 1 minus x raised to the power of 2. And the second derivatives of x is equals to 2 over 1 minus x raised to the power of 3, or 1 over x cubed. And the third derivatives of x is equals to 3.2 over 1 minus x raised to the power of 4. And the fourth factorials of x is equals to 4 times 3 times 2 over 1 minus y raised to the power of 5. And the fifth factorial of x, the fifth derivative of x is equals to 5 times 4 times 3 times 2 over 1 minus over the quantity 1 minus x raised to the power of 6. So that's all. Thank you and God bless.